Hi guys, here we are. It's our last chapter of the year. I know you're so excited. For our last chapter, we're going to do circles. Today, we're going to start with basic circle terminology and finding some central angles inside a circle. So I'm going to go through the notes, except I'm not going to spend a lot of time filling in this vocab for you. I would ask that you would actually look on the completed note sheet and fill in from there, or just print out the PDF of the completed note sheet at this point. Okay, so here's what we have. So most of you guys know the terms radius and diameter. So in this picture, you can see the radius is located here. Radius comes from the center of the circle and touches a point on the circumference of the circle. Usually it's a segment. And then there's the diameter, which is made up of 2 radii. So diameter is equal to 2r, 2 radiuses. Now, there are other terms inside the circle. For example, there is the chord, and the chord touches both ends of the circle or on its circumference. Notice the chord stops. Here's our chord in the circle. There's also a secant, which is a term you might not have heard of. A secant actually goes through the circle. It starts on one point of the circumference, and it actually goes through the circle all the way through. See that? Boop, it comes out over here and over here. Any portion of the circumference of the circle is called an arc. You can see that example here. And a tangent is a fancy term. A tangent touches the circle in one spot on the circumference, and tangents generally fall outside the circle since they're only going to touch in one spot. And up here is an example of our tangent. Most of you guys, you know your formulas for some let's try that again. Circumference, it's pi d. Or it can be 2 pi r. And your area of your circle is pi r squared. We'll do a little practice with those later on. Okay, so again, I would ask you to read through these definitions or just print the PDF of the answer key. That would be fun. Let's look at the Let's Practice section, which will be similar to some of the questions on your homework. We can do it. Okay, so it says, use the circle with center R to answer the following questions. Name the radii. Notice it's plural. That means there's more than one. So in the circle, you start at the center, and the radii in this case are RA. We have RX. We have RY. And we have RB. That was super fun. There were 4. Next question says, name the chords of the circle. Now the chords touch the circle on the circumference in 2 places. So for example, if you look up here, you have AX, that's a good example, and you also have RY. But did you know there are 2 fancy chords? Those are the diameters of the circle. Even though they're diameters, they're fancy chords. So we could also include A, B, and we could include X, Y as chords. So even diameters can be chords because they touch the circumference in 2 spots on the circle. Name the diameters, we just did that. They're A, B, and X, Y. And that was fun. We know our basic parts of our circle. Let's try some more. So we're using the same picture, and it says if A to R is what we're looking for, and we know A to B, so the whole diameter, and I'm trying to find a radius. The diameter is 18, well, diameter is equal to 2 radii, so that means our radius has to be 9 in that case. Super easy. Now it says find AR and AB if we know RY is 10. Well, RY is another, is another radius. So RY is 10, that means all the radii are 10. AR is 10, and AB was the diameter, so that's 20. They're asking, is AB congruent to XY? Well, AB is a diameter, and XY is a diameter. They pass through the center, that is the same. So are they going to be congruent? Yes. All diameters of a circle are congruent. So if they're diameters of the same circle, they have to be the same size. That was so fun. Let's do some more. Oh, here we go. Okay, so we now have use the circle with center C. Notice they told us that C is the center to find each of the following angle measures. Oh, look at that. There's a little right angle box in the center there. And that's showing me that this angle is 45. And if that's 90, guess what? That guy is 45. I can use some other fun facts. I know there's a straight line here. So if this is 60 and this is 45, they have to add up to 180. So this is going to be 75. And likewise, on the other side of this straight line here, if that angle was 45 because of the right angle, over here on this side, it's 135 using my supplementary fact, which we did at the beginning of the year, which seems like a long time ago. Long time ago. Okay, so ready? Here we go. We want to find angle SCT. Whoa, I did that already. SCT, 75. Angle SCU, 75 plus 60. Going to add those together, and I got 135. That was fun because it's vertical. No, it's not. Just kidding. Okay, so now we want SCQ. SCQ, 45 and 45, 90. And QCT, wow, 135, right? Q to C to T. Oh, just kidding. It's 90, right? Plus 75. So is that 165 on there? That was fun. Now, how did I know to go in that direction? I don't know. Just do it. Okay, so now our next question down here, a little bit trickier. Okay, so this segment BC is a diameter of circle A. When I approach these problems, I like to mark off all the radii in the picture because they're all going to be congruent to each other. So here's a radii, here's one, and here's one. Now, when you mark those radii, you can see that there's isosceles triangles now. So this guy over here is 26. Because if this angle is 26 up here, these two are isosceles. Remember, those two angles are going to match each other, which means this angle up here is 18. Because these two sides are isosceles and that angle is 18, and so is that then. Now you can use your supplement facts. Angles in a triangle have to add up to 180. So this guy in the middle is 144. And this guy over here is 128. And then that means this whole angle here is going to be 88. And how am I getting those facts? That's a circle in the middle. They have to add up to 360. Okay, so here we go. Angle DAB, D-A-B. D-A-B, I did it already, 144. Angle B-A-E, I did it already, B-A-E, 128. Because of those isosceles triangles with the radii, it helped me find those angles in the center. And then D-A-E, whoa, just kidding, dropping the stylus, D-A-E is 88 on there. I found all my angles. That was fun. Let's try the last bit of this. It says, find the area of a circle with a circumference of 6 pi. Whoa, circumference is pi d. Well, if it's 6 pi, and that's pi d, that means the diameter is 6, or my radius is 3. Okay, so if I know my radius, now I can do pi r squared to find the area. 3 squared times pi, 9 pi for my area. This time they tell me the area is 64 pi. Well, that's what pi r squared is. In other words, r squared is 64, where the radius is 8. Now I want to find the circumference. Circumference is 2 pi r, or pi d. So it's going to be 16 pi, because 2 times 8 is 16. These are fun. Find the radius of a circle so that its area and its circumference have the same value. Look at this problem. This is going to be fun. I made it up. Okay, so here we go. Its area and circumference have the same value, area value, and we want to find the radius. So pi r squared has to equal 2 pi r. See how I did that? They both have radius in there. Look what happens. Cross off the pi's. So r squared equals 2r. Oh boy. Let's move the 2r to the other side, set it equal to 0, and factor it. Look what I can take out of there in r. And r minus 2 is going to equal 0. And now I can solve this. R can equal 0. I can't remember radius is 0, but I can have a radius of 2. So 2 is the value where the area and circumference of a circle are equal. Bet you didn't know that. All right, you guys have fun trying the homework on that. Enjoy lesson 1 of circles. We only have one more this week.